Hello, everyone. Once again, this is Peter from Learnwithuncletee, and we are still continuing the series on calculus, which basically we have started the integral calculus, and this is the second tutorial video on integral calculus. So now, basically, we're going to go straight into uh, the work schedule. Now, let's take it from this perspective. We are going to start from integration by substitution, or let me say integration just by basic substitution. So we have integration by substitution. So we are going to consider a series of questions, and that is what is going to make us to understand this method of integration. So, but one thing I want you to know is that integration by substitution is kind of a synonym of when you are differentiating using your function or function, or let me say your, how will I put it? That's your chain rule. So, but not directly connected, but it's just as if that we are trying to introduce a third party and we are now integrating with respect to that third party. The only difference is that we are not bringing in the formula for chain rule, which is your the y dx is equal to the y du times the u dx. So now let's consider an integral. Let's say we have integral, we have to evaluate integral f of ax plus b with respect to x, and that will be dx. Now, once we evaluate integral f of ax plus b with respect to x, what we have inside the brackets, if we take it to be a letter, the most common third party letter that we use in calculus is always u. So if we say that let u to be equivalent to ax plus b. Now, take a look at this. We are going to represent ax plus b as u, which means that this we can be represented as integral f of u dx. But the thing is that if we want to integrate f of u, we can't integrate it with respect to dx. We have to integrate it with respect to du. Since you have defined a function between u and x, it means that you can find du dx here and now make this dx the surrogate formula. So take a look at this. If I say if u is equal to ax plus b, we know that du dx, when you differentiate ax, you are going to get a. When you differentiate b with respect to x, you are going to get 0. So from here, it means that du is equivalent to a multiplied by what? Dx. So what it means therefore is that dx is equal to what? Du divided by what? A. So what it means is that integral f of u dx is now the same thing as integral f of u multiplied by dx, and dx is now what? Du over what? A. So this will now give us integral f of u times du divided by a is the same thing as 1 over a f of u du. Now we have an integral law that states that once you have a constant in an integral, you can actually factorize that constant out. So this is the same thing as saying 1 over a, factorizing 1 over a as a constant, still multiplied by integral f of u du. So it means that if you integrate integral f of ax plus b dx, is going to give you 1 over a integral f of u d what? Du. So basically, we are going to do applications. Let's take a first example so that you will understand what we are saying here very much better. So let's say example one. Now, for example one, let's say we have to evaluate integral 2x plus 3 raised to the power of 5 dx. Now, basically, you can just apply this as a formula straightforward, but let's use the substitution so that you discover the process. Now, the first step is that we are going to say that let u to be equal to what? 2x plus what? Plus 3. So find our du dx. Du dx is going to give us what? 2. When you differentiate 2x plus 3, you get 2. So what it means is that dx now is equivalent to what? Du divided by what? 2. Now, integral 2x plus 3 raised to the power 5 dx is now the same thing as integral 2x plus 3 is now u. So this will be u raised to the power of 5. Dx is now what? Du divided by what? 2. So we can factorize this 1 over 2 out. This will give us 1 over 2 integral u raised to the power of 5 du. So basically, what this gives us is that we have 1 over 2 multiplied by, if you integrate u raised to the power 5, you are going to get u raised to the power 6 divided by 6, that's using the AD method, plus an arbitrary constant of what? Arbitrary constant of c. So what this therefore means is that we have 1 over 12, 2 times 6, that will give us 12, u raised to the power 6 plus what? Plus c. Now, this is 1 over 12. Our u, we took our u to be what? 2x plus 3, so we can just substitute it back. 2x plus 3 raised to the power of 6 plus what? C. So it means that integral 2x plus 3 raised to the power of 5 dx will be equivalent to what? 1 over 12, open bracket, 2x plus 3 raised to the power of 6 plus c. And that will be the final answer to that question. So now let's take another question. So let's say example 2. Let's say we have integral 3 divided by 4x minus 1 raised to the power of 3 dx. So we have integral 3 raised to the power of 4x minus 1 raised to the power of 3 dx. So we use the same approach. We say let u to be equivalent to 4x minus 1. So what it means is that the u dx is going to give us, when you differentiate 4x, you get 4. When you differentiate minus 1, that will be 0. So from here, it means our dx is equivalent to what? Du over what? Du over 4. So it means that integral 3 divided by 4x minus 1 raised to the power 3 dx will be equivalent to integral 3 divided by 4x minus 1 is now u. So this is u raised to the power of 3 multiplied by dx, which is now what? Du over what? Over 4. So this will give us, we can factorize 3 over 4 out. So this will be 3 over 4 integral 1 over u raised to the power of 3 du. So this will give us 3 over 4 integral 1 over u raised to the power 3 is the same thing as u raised to the power minus 3 du. So basically what this gives us is that if we use the AD method to solve this will give us 3 divided by 4 multiplied by, if you add 1 to the power, that will be u raised to the power minus 3 plus 1, which is minus 2, divided by that new power minus 2 plus arbitrary constant c. So this will basically give us minus 3 divided by 8 multiplied by 1 over u raised to the power 2 plus arbitrary constant c. So your final answer will therefore give you minus 3 over 8. You substitute your u back to be 4x minus 1, which will be 4x minus 1 square plus c. And that will be the final answer to that question. So basically, you're going to understand that in integrating functions with substitution is a bit quite easy. So though, but there's a technique that concerns integration, because you have to study your question first to see what method you are actually going to use. So we're going to take 3 more examples before we bring this particular session to an end. So let's take a third example. Now let's say example 3. So for example 3, we have integral cos 7x dx. So we have integral cos 7x dx. Same approach, we'll say that let our u to be equal to 7x. So if u is equal to 7x, it means that du dx is going to give us 7, which means our dx is equivalent to du divided by 7. It therefore means that integral cos 7x dx will give us integral cos 7x is now u, so that will be u times dx, which is now du divided by 7. So integral cos 7x dx will give us, you factorize 1 over 7 out, that will be 1 over 7 integral cos u du. So this will give us 1 over 7 multiplied by, when you differentiate cos, you get sine. So that will give us sine u plus arbitrary constant. So therefore, we took our u to be what? 7x. So it means that this will give us 1 over 7 sine 7x plus arbitrary constant c. And that will be the value for the integral of cos 7x dx. So let's move to the next example now. So example 4, we have integral sine half x dx. So we are to evaluate integral sine half x dx. So same approach, we'll say that let u to be equal to 1 over 2x. It therefore means that our du dx is going to give us, du dx will give us 1 over 2. So from here, it means that dx is equal to 2 du. So what it therefore means there is that integral sine half x dx is now equivalent to integral sine half x is now what? U, multiplied by the x, and the x is now what? 2 du times 2 du. So therefore, this will give us, we can factorize the two out. That will be 2 integral sine u du. So this will give us 2 multiplied by, if you integrate sine, you are going to get minus cos, so plus arbitrary constant c. So 2 times minus, that will give us minus 2 cos our u is what? 1 over 2x plus arbitrary constant what? Arbitrary constant c. And that will be the final answer to that question. So we'll take the last question now, which will be example 5 for this tutorial. So example 5, we are to integrate integral exponential minus 5x plus 2 with respect to x, which is dx. So same approach, we'll take u to be minus 5x plus 2. So if our u is equal to minus 5x plus 2, what it therefore means is that du dx is going to give us what? Minus 5. So if you make dx the serial formula, dx will give you minus du divided by what? 5. It therefore means that integral e raised to power minus 5x plus 2 dx is the same thing as integral e raised to power minus 5x plus 2 now is u. Our dx is now what? Minus du divided by what? 5. So don't forget this is multiplying this. So we can factorize minus 1 over 5 out. This will give us minus 1 over 5 integral e raised to power u du. So if you integrate exponential x, that is e raised to power of x, you still get e raised to power of x. So it means that if you integrate exponential u, which is e raised to power u, you're still going to get e raised to power u plus arbitrary constant c. So therefore, this will give us minus 1 over 5 e raised to power, our u is what? Minus 5x plus 2, everything plus an arbitrary constant c. And that will be the final answer to that question. So basically, for this tutorial, this is how we integrate by basic substitution. And it's practically very simple. Just consider the question. We are still going to go much deeper into other methods so that you understand the differences. So, but on this note, this is where we're going to bring this tutorial to an end. Once again, this is Peter from Learn with Uncle T, and make sure you like, share, and subscribe to this channel. See you in the next tutorial video.